What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. All right, so in this video, we're going to be talking about IPv4 addressing, its address structure, public versus private IP addressing, loopback and local host IPs, and APIPA addressing. All right, so let's start off with talking about IPv4 addressing. So although IPv6 is increasingly being adopted in corporate networks, IPv4 is by far the most popular layer 3 addressing scheme in today's networks. And for brevity in this video, the term IPv4 address is going to be used interchangeably with the more generic term IP address. Now, devices on an IPv4 network, they use unique IP addresses to communicate with each other. And metaphorically, you can relate this to sending a letter through the postal service. So you place a destination address on an envelope containing the letter, and in the upper left corner of the envelope, you place your return address. Similarly, when an IPv4 network device sends data on a network, it places both a destination IP address and a source IP address in the packet's IPv4 header. All right, so let's move on and talk about the IPv4 address structure. So an IPv4 address, this is a 32-bit address. However, rather than writing out each individual bit value, you would write the address in what is called dotted decimal notation. So consider the IP address 192.168.1.45. Notice that this IP address is divided into 4 separate numbers separated by periods. And each number represents 1/4 of the IP address. Specifically, each number represents an 8-bit portion of the 32 bits in the address. Because each of these 4 divisions of an IP address represents 8 bits, these divisions are called octets. So for example, as you can see in this picture right here, you have the binary representation of 192.168.145 down here at the bottom. All right, so let's move on and talk about public versus private IP addressing. So a public IP address, which is also known as an external IP address, this is assigned to every device that connects to the internet, and each IP address is unique. This addressing scheme makes it possible for the devices to find each other online and exchange information. And the user, they have no control over the public IP address that is assigned to the device. The public IP address is assigned to the device by the ISP or the internet service provider as soon as the device is connected to the internet. And also a public IP address, this can be static, dynamic, or it can even be shared. In IP networking, a private network, this is a computer network that uses private IP address space. And these addresses are commonly used for local area networks and residential, office, and enterprise environments to allow for devices to communicate with each other on the same network. And private network addresses are not allocated to any specific organization, and anyone may use these addresses without approval from regional or local internet registries. Now, an IP address is considered private if the IP number falls within one of the IP address ranges that are reserved for private networks, such as a local area network. And the IANA, or the Internet Assigned Numbers Authority, they have reserved the following 3 blocks of the IP address space for private networks or local networks. So in order to communicate with the outside world, these IP addresses must be translated to a public IP address using what is called Network Address Translation, or NAT. And as you can see here on your screen, you have 10.0.0.0 all the way through 10.255.255.255. And within that IP address range, you can get upwards of 16.7 million IP addresses. Then the next one, starting with 172, you can get upwards of 1 million IP addresses. And then the one that's starting with 192, you can get a grand total of 65,536 IP addresses within that IP range. All right, so let's quickly talk about loopback and local hosts. So the loopback address, which is 127.0.0.1, this is a special IPv4 address used for testing and troubleshooting network software. It allows a device to send traffic to itself without requiring a physical network connection. And this is commonly referred to as a local host. All right, so let's move on and talk about APIPA, or automatic private IP addressing. So if a router does not have enough IP addresses for the devices that need to connect to it, APIPA IP addresses are assigned, and APIPA IP addresses range from 169.254.0.0 all the way through 169.254.255.255. But a PIPA IP addresses are assigned to devices arriving after the pool of addresses are used up. And once again, a PIPA, this stands for Automatic Private IP Addressing, which is a feature in Windows-based operating systems that enables computers to automatically self-configure an IP address and subnet mask when their DHCP server isn't reachable. And the PIPA service checks regularly for the presence of the DHCP server every 3 minutes. If it detects a DHCP server on the network, the DHCP server will replace the PIPA networking address with dynamically assigned addresses. So exactly what is the purpose of a PIPA? So a PIPA, it was designed as a solution for quickly setting up a localized network without the need to configure a DHCP server or the need to statically assign IP address information. However, there remains a need for devices on this localized network to perform name resolution and discover network services. Now, fortunately, these needs are covered by what is called zero configuration. And zero configuration, this is a technology supported on most modern operating systems, and it performs 3 basic functions. The first is called assigning linked local IP addresses. So a linked local IP address, this is a non-routable IP address usable only on a local subnet. A PIPA, this is an example of a technology that assigns linked local IP addresses. The next function it does is resolving computer names to IP addresses. So multicast domain name systems, this is an example of a technology that can resolve computer names to their corresponding IP addresses on a local subnet without the aid of a DNS server or a WINS server. And then the third thing it does is locate network services. So examples of service discovery protocols include standards-based service location protocol, Microsoft Simple Service Discovery Protocol, and Apple's DNS-based service discovery. Now, if devices supporting these 3 zero configuration features are interconnected on a local subnet, they can dynamically obtain linked local IP addresses, resolve one another's names to IP addresses, and discover services that are available on a network. All right, so that was a lot of information. So let's go ahead and do a check on learning exercise real quick. So the first question is, which of the following IP version 4 address ranges is reserved for private networks? Would it be 169.254.0.0? Would it be 192.0.2.0? Would it be 172.16.0.0? Or would it be 224.0.0.0? And the correct answer is it'll be 172.16.0.0 through 172.31.255.255. So private IP addresses, they are assigned for use within private networks such as local area networks and the Internet Assigned Numbers Authority. They reserve 3 address ranges for private use. In choice A, that is in a PIPA range that is used when a DHCP server is unavailable. Choice B, that is a reserved block for documentation and testing. And choice D, that is for multicast addressing. Next question. What is the primary function of the IP version for loopback address 127.0.0.1? Is it to assign an IP address when a DHCP server is unavailable? Is it to allow a device to send network traffic to itself for testing? Is it to provide access to a private network? Or is it to translate private IP addresses to public IP addresses? And the correct answer is it is to allow a device to send network traffic to itself for testing. So the loopback address is used for testing and troubleshooting network software. When a device sends data to this address, it effectively communicates with itself, making it useful for testing network stack functionality without requiring a network connection. And our final question. A computer on the network receives an IP address in the range of 169.254.0.0 through 169.254.255.255. What does this indicate? Is it the computer has successfully obtained an IP address from the DHCP server? Is it the computer is using a private IP address? Is it the computer has been assigned in a PIPA due to DHCP failure? Or is it the computer is using an IP address for multicast communication? And the correct answer is the computer has been assigned in a PIPA due to DHCP failure. So when a computer is configured to obtain an IP address automatically but cannot reach a DHCP server, it assigns itself an address in the range of 169.254.0.0 through 169.254.255.255. Now, this allows for local communication, but it prevents access to external networks such as the internet.